Thank you. It's been, I found the day superb, so thank you very much for the invitation to present today. I'm joining you from Canberra, from Ngunnawal and Ngambri country, and I'll be speaking to you about the Exploring for the Future program. So what is it? Well, it's Geoscience Australia's premier pre-competitive geoscience program. It's an investment of $225 million by the federal government, and it started the first phase in 2016 and went to 2020. That phase was predominantly focused in Northern Australia, but it actually started in South Australia in the Kumpana province. So I can basically say that we're back because we enjoyed working with the Geological Survey of South Australia so much. This phase of the program has 8 projects. 3 of them are continental in scale. The Australian Resources Framework is acquiring the big data sets that may be feeding into Stefan's stack, for example, and also has an emphasis on national mineral potential assessments, and I'll go into why in a moment. The Australian Futures Energy Resources Project, which is looking at carbon capture and storage, hydrogen, and also at sedimentary basins in Central Australia, such as the Perdurka and Simpson. Across the NT and South Australia border. The National Groundwater System Project is providing an inventory of the hydrogeological units across the whole country. And there are 3 regional projects. We are continuing our focus between Tennant Creek and Mount Isa and extending it eastwards towards Georgetown. And the 2 new ones are the Darling and Amona Delamerian, which we've already heard a lot about and references to it. So that's of great interest to South Australia, and the Officer and Musgraves project. The Delamerian is focused on minerals and groundwater, whereas the Officer Musgraves is focused mostly on energy and groundwater. And there are 2 support projects: enhanced data delivery, so this is talking about portals, carrying on with the sort of thing that we just heard about, and the geoscience knowledge transfer, where we're particularly interested in expanding our engagement with stakeholders so that we return the knowledge that we get from the geoscience to the broader community. So what in detail are we actually trying to do? So this next slide shows, I suppose, a cartoon depiction of what the program is trying to achieve. In essence, it's to support a strong economy, resilient society and sustainable environment for the benefit of Australians through an integrated geoscience understanding of our mineral, energy and groundwater potential. Why those 3? It's because they are all in the subsurface, and hence understanding the geology, just surveying the country, is pertinent to all of them. We spent the majority of our efforts collecting that data and coming up with the toolboxes either to acquire it, to quality control it, process it, and to store it and deliver it. That's the vast majority of our work. But we then also take that information to learn about the geological architecture from the surface down to great depths, and use that information to put the mineral, energy, and groundwater systems into their context, as well as work out which are the new prospective regions. And that, I think, kind of summarizes most of the kind of talks that we've heard today also. So the program is very well aligned with what the survey is doing. We deliver that, and our intended outcomes are to stimulate investment, increase engagement, both nationally and internationally, and transform industry and indeed what we're doing internal at GA. And all of this is to increase discovery, improve management of natural resources, and grow regional development, so that Australia is prosperous, sustainable, secure, and informed in its decision-making. This bow tie diagram effectively summarises what my talk is going to be about, and I'll be stepping through it bit by bit. So, starting off with data and the toolbox and geology components. So we're going to start off from the very surface, and we're going to progressively get deeper and deeper as we go through. So imminently, in the next week or 2, we'll be releasing the Barest Earth from Sentinel 2. So as Paul had to say, talked about zooming across the country. This data set will help as it goes down to a resolution of 10 meters, and it helps to strip away that first layer of cover, not the sediments, but the vegetation. On the left-hand side, you can see a regular satellite image, and you can see a lot of the I suppose, vegetation and patchwork of different paddocks and so on. On the right-hand side, what we've done is we've queried the various passes of the Sentinel dataset to look at the Earth at its barest, and we're able to then link in to the spectral information that is held in that back to the soils and the rocks that are down there. So we can link back to Georgina's spectral data that she was talking about earlier today. So look forward to that, and it should be released in the next week or two. If we keep moving in terms of characterizing the surface, like Anna was talking about, the surface, the biogeochemistry and the soil chemistry, what we're trying to do is come up with the first quantitative observational data set of the mineralogy across the whole country. And the first bit that is currently in the review is the chemistry of the National Geochemical Survey of Australia across the Delamerian and Curnamona region, which is this area in through here. And you can see it shows the distribution of the major minerals in that. There is also an associated component to this done with Curtin University, which is focused on the heavy mineral concentrates and the distribution of those, which are pathfinder for a whole series of different mineral deposits. We also delved down into much more detail over the Curnamona region because it's an area that's seen a lot of effort over a long time, and we thought this was an opportunity to bring all the bits of chemistry information that have been collected previously and supplement bits that may be lacking in order to understand the dispersion of I suppose, geochemistry, all the way from the hard rocks down to the depositional site. So Ivan Schroeder's leading that work at GA. So moving a little bit further down in the lithospheric column, we're now looking down to about 200 to 300 meters at depth. And this is the AusLAMP program. We're particularly, I suppose, enamored with this, given the new perspective that it provides. It's the world's largest airborne electromagnetic survey. When we started, I think there were great questions whether these 20-kilometre flight lines were going to provide much insight across Australia. But since then, there's been great uptake with the geological surveys. And recently, we've released it with GSSA, the Eastern Corridor region, up in through here, which covers that Delamerian area that we've been focused on today. And the Geological Survey of Western Australia and us have recently released this patch down the southwestern part of Western Australia. So they're the new two kids on the block, and you can head to the website and the portal to look at them. But what do they show us in detail? So let's have a look at a profile across the Adelaide Rip Complex and Arawi Basin and out into the Murray Basin itself. This is the first time that parts of the Adelaide Rip Complex have had this type of information from it. And what you can see is that we can I suppose, interpret almost down to the formation level with this, which is incredible, I think. This is an initial interpretation in terms of what we might be able to see and what sort of level we get from Ian Roach, and we're currently progressing this. And we're also planning some infill of these 20-kilometre spice surveys across that eastern corridor down to about 5-kilometre spacing. So it's still really, really regional, but it's in order to be able to cite future National Drilling Initiative projects with MinEx CRC in the Delamerian. Now, these sorts of data sets and the continuity of able to kind of piece them together don't happen by accident. Well, today spoke about the work that is happening at CSIRO on probabilistic inversion of AEM. This is an example of that, but it's across the test range across Menindee. And what's so important about this is that given that we've got drill hole information around here and we've got multiple different types of systems which have acquired information across it, we can compare the performance of helicopter and fixed wing system. And it's been an issue, you know, do you go for a fixed wing? Do you go for a helicopter system? What you can see here is the 5th percentile, 50, mean, 95th percentile of a helicopter and a fixed wing system acquired in 2015 and 17. And I hope that you can appreciate from this that they're actually very, very similar. We haven't been able to do this probabilistic inversion on fixed wing systems until very, very recently. And it's one of the examples of our investment into Toolbox development associated with these big data collections. And there is similar effort going on in this field into MT and passive seismic, data acquisition, machine learning, and so on. But I can't go into all of it in 15 minutes, even though I would really like to, and I'm going to try squeeze as much as I can. So moving further on, deeper down, the plan is across the Delaware region is to acquire deep reflection seismic profiles. The outline of them is here, and we've started notifying people about this upcoming survey across the region. In the officer area, in order to maximise the value of pre-existing datasets, we've had a survey with the Geological Survey of South Australia that was acquired in 1994, reprocessed, as well as about 1,400 kilometres of industry seismic. And both of those are available through our data delivery system with the links provided down there. Now, with all these datasets, of course, we want to grow our understanding of geology. So one of the things that we're aiming for in this program by 2024 is to have a layered solid geology of the entire country. Now, obviously, this isn't in as much detail as perhaps what Tom showed, but indeed we're trying to bring in Tom's interpretations, and hopefully it'll be any revised versions, but I see that the drill holes were largely hitting the things that Tom predicted. So well done there. And the idea is to be able to also layer them in those focus regions on depth to Cenozoic, Mesozoic, Paleozoic, and Neoproterozoic. So we're building up this layered picture of Australia. But we're also trying to populate that information with what we know about the stratigraphic units. So this links back to the Australian Stratigraphic Units database, which is maintained by Geoscience Australia with information from the states. And we also try and provide new bits of information. And one of the really exciting things, which is coming around the corner, probably another year or so away, is the National Metamorphic Map by Ben Goscombe. There's a little snippet about it in the extended abstracts from the previous phase, which was released in 2020, but it's something really to look forward to. So moving even deeper to that, JP provided an excellent outline of how the passive seismic method works, which is great because I don't need to cover it here. But one of the great ambitions of the program is to deploy at the same time a 200-kilometre spaced grid of seismometers across the whole country. So they're the red dots there. We have about 15% of these are already collecting information. About 50% are cleared for collection, and we're continuing stakeholder engagement to get the other ones in. But it's looking promising at the moment. And one of the big motivations for this is the map that was mentioned by Adrian Fabrice, the Lithospheric boundary. In the publications by Mark Hoggart, you will see in the supplements there are multiple versions of the Lithospheric boundary, and that's because in some areas there's only one station, and we kind of don't know in terms of its quality whether we should include it or not in the inversions. And that's the sort of, I suppose, we want to get away from those types of levels of uncertainties, because what we're learning is that these mantle data sets are so important in terms of narrowing the search space, so finding the broad regions of where to explore next. Now, we don't want to stop just there. We also wanted to turn our information in the mantle into geology, and hence we've been collaborating with Juan Carlos Alfonso on a thermochemical model of Australia. There's a summary of where we've got to so far by Marcus Haynes in that extended abstract volume that I've previously mentioned about on our website. And suffice to say, we're continually progressing with that model, and we hope to have it out shortly. So moving further down, how does that sort of information tie in with the systems and resources potential of Australia? So in terms of the mineral space, we will continue to undertake mineral potential assessments, a bit like this one, but in much more detail than that one. Our current focus for this round of the program is sedimentary-hosted base metals, iron oxide, copper golds. We've got a model of that across Northern Australia. We want to extend it across all of Australia, and also alkaline-related critical mineral systems. And in the Darling, Cunnamunna, Delamerian region, we want to look at convergent margin systems and broken hill type base metal assessments. So, and in certain areas, like for example, building on these types of mineral potential maps, we want to do follow-up work. There was an excellent session yesterday on the Stewart Shelf, which I got to tune into a bit of that. And in it, David Champion presented our work that is trying to look at what are the source rocks across this region. He sampled over 24 drill holes with over 1,000 samples, along with David Houston. And there was a nice happy snap in the core library of them there. And we haven't been able to do that physically. So it's been so great to use the information in Georgina's presentation on the spectral information. We've been delving into that to be able to, I suppose, provide our requests for which samples we would like collected from that area. And all of these will be analysed for majors and trace elements, petrography, stable isotopes. And like we did in the Carpentaria region, of Australia, we're able to, I suppose, provide evidence of fluid flow, which did result in significant tenement uptake across regions. And I suppose the point here is that if we believe in mineral systems, we believe that there is a series of order questions that we can pose in terms of assessing that. And this work is building to provide what that list is and how can we step through the other basins which are along this this worm, which has been derived from the lithosphere boundary work. Now, in that work, what we did is we looked at the statistical relationship between deposits and, in that case, the lithosphere boundary, which is derived from passive seismic data. Here we're continuing that work and we're expanding it to other datasets. This is just one example of that style of work related to the AusLAMP dataset, and it's focused on southeastern Australia and it's focused on convergent margin. The reason why I think it's important is for the reasons that Wei outlined in his talk in terms of, well, how can we assess the fertility of these regions? He provided some geochemical means into that problem, but there is also a geophysical means. We often think that MT is imaging the source regions of these systems, but is it really imaging for all type of mineral systems? You know, can we be a little bit systematic in terms of how we think about that problem? So what we did is we took this region along with as many other coverages of MT globally and looked at the distribution of orogenic gold, porphyry copper, and VHMS deposits. And what we did is we plotted a distance between the random distribution of locations of these deposits with respect to the 100 ohm contour, that's the half space that we're starting with depth. And this color that you see here is the strength of that relationship. So the warmer the color, the bigger the difference from random, which is good. And the black line shows you just what that maximum difference with depth looks like. This is the Dmax value. We're able to provide the Kolmogorov-Smirnov statistic to work out, well, what is the probability that what we see is actually from random? And what we find from orogenic gold in the crust is that it's far from random. You know, it's a chance greater than 1 in a trillion. Which is, you know, really, really strong. And he kind of places that question, you know, is orogenic gold related to mantle-related processes or crust-related processes? Given that the orogenic deposits are old and the convecting mantle, where we see the signal at the moment, has changed since that time, it does seem as if the crustal signal is the most significant. As we go to porphyry copper deposits, we find that in Australia, there is actually a very low, I suppose, relationship. But globally, because porphyry coppers are young, there is a relationship with features in the convecting mantle. Whereas volcanogenic hosted massive sulfide deposits, there is no statistical relationship. You do not want to use VHMS in order to narrow down your search space. I suppose MT for VHMS deposits, well, at least with our current data set that we know. So I think that's really useful. We're also, I suppose, trying to, link these to actual rock samples. And across South Australia, we've got a project with the ANU, which has collected information across 19 kimberlite pipes, all the way from the Western Gawler right through to the Delamerian. And we're just trying to finalise that paper with Zach. So that should be coming out shortly. But as we've heard from Paul Hethersay, critical minerals are the flavour at the moment. But unlike the deposits that we've been, I suppose, researching and learning about for centuries and mining, the knowledge base on these is quite low. So what we've done is we've teamed up with the Geological Survey of Canada and the United States to come up with the critical minerals in ores database. This is it here. You can access it at that site just here. It contains over 7,000 samples from over 1,500 deposits across 60 countries. And they're all classified by deposit type. In other words, we can look at the systematic distribution of critical minerals in these different types of deposits and look for opportunities in terms of, well, which ones would you go after if you wanted to get those critical mineral credits from the major commodities that we're mining. And there's a whole talk that we could go into on this space in terms of all the exciting things that we're finding. But I point you to that website where there are where there are links to those types of presentations. On the critical minerals theme, hydrogen is hotly, I suppose, related to that, to the decarbonisation of our energy sources. And in that, we've teamed up with Monash University to come up with the Hydrogen Economic Fairways Mapper tool. So what you're seeing here in this colourful map is the net present day value of an assessment for green hydrogen, so from renewable sources. And it basically paints out these fairways when we can find it. On the bottom, you can see where the renewable I suppose, sources of hydrogen and which type of renewable power would be used to generate that hydrogen. And in South Australia, it does seem as if wind is the major advantage. And in terms of renewables, it'd be gas or brown coal. Now, I'll circle back around to these in a moment. In the hydrogen space, we also have a program looking at natural hydrogen distribution, and there's a wonderful paper by Chris Borum in Apia Journal. It won the best paper in the conference, which looks at the distribution of hydrogen across Australia. So I refer you to that if you're interested. But moving on from the kind of the hydrogen perspective, we can link our understanding of mineral deposits and our understanding of the distribution of green, I suppose, hydrogen sources, and look at the opportunity for green steel. And this is another great bit of work with collaboration with Monash, which was presented at the Asian Clean Energy Summit, where it highlights that there is a correlation between the areas which have potential for green hydrogen generation and the distribution of iron ore deposits. And the reason for this is because those regions have infrastructure on which the hydrogen industry can piggyback. On the right-hand side, what you can see is the estimated cost of steel production. In Pilbara, wind only, wind and solar, and in South Australia with wind, solar, and the grid itself. So the presence of the energy grid across South Australia around these regions is really, really significant, and it actually provides a competitive advantage for I suppose, that type of industry to develop. In terms of the energy work, there in the Central Basin, so here they are, is the region that we're focusing in. At the moment, what we're doing is doing a gap analysis, reprocessing seismic, looking at, I suppose, well failure analysis of previous drilling across the regions, and then we'll continue with, I suppose, classic, I suppose, petroleum systems analysis, as well as unconventional in those basins. Now, this work is piggybacking from a whole lot of work which is happening in the groundwater space. So there, in the Great Artesian Basin project, they've been looking at providing a sequence stratigraphic framework for the Great Artesian Basin, or the Eromanga Basin, which is shown here. And we're using it to, I suppose, piggyback into the National Aquifer Framework, which is held by BOMs. This is part of that synthesis of the hydrogeological units. But it also provides really important constraints on the subsidence histories and the I suppose the energy potential of the basins which are buried by these sediments, because some of the I suppose outstanding issues about preservation of those systems are related to, well, what happened after the charge. So we provide all of our outputs through our web portal, publications and highlights, and communications like this. So thank you very much for inviting me. I do, I suppose, point you to our portal. I think it's great. It's amazing that we can now have these 3D immersive environments that can also provide drilling results in near real time. And I do encourage you to visit the EFTF website, where you can sign up for our monthly newsletter. So what sort of outcomes are we aiming for? Well, in Northern Australia, the program was exceedingly successful. I've never seen such success previously. We went to areas which were underexplored, and as a result of this work, over 165,000 square kilometres of real estate was pegged, linked to the program, but it wasn't pegged everywhere. So we're interested in people picking up the right ground, and you can see there's, for example, a big hole over here. That's an area of really, really thick lithosphere where there's mineral potential above it. But the thing that we're really after in the long term are discoveries. And the latest great news story on this is the discovery of Julimar in Western Australia by Chalice, and they've been very generous in their attribution to us. That's one of the catalysts of them going into the region where they went to explore in was this nickel mineral potential map. That map is a synthesis of our geophysical, geological, and geochemical information, and this is really where that program is going, not only for minerals, but also for energy and groundwater, in terms of building on all those different, I suppose, strands of geoscience. So I hope that soon Petter will have more activity, and there'll be less, I suppose, that pyramid that Paul had to say will become steeper in terms of more project progressing vertically because they're more successful. So in conclusion, Exploring for the Future has a strong presence in South Australia. There is lots of big data collection and analysis. There are multiple resource assessments happening. And we hope that this will accelerate discovery and also inform responsible management of resource extraction and of our groundwater. So thank you very much.